and replicate data. This is one of the aim of your distributed DBMS. What is that aim is? Transparent management of distributed and replicated data. Now, whether the data is replicated or not will be taken care by our this particular database administrator. The database administrator he is going to take care of how the data is distributed, where the data is, what type of data is distributed to various sites, and whether the data should be replicated at 2 or 3 sites or not. All those things will be decided by the distributed database administrator. So like a DBA in our DBMS, we have a distributed database administrator. He will take care with the help of, there are two particular people. One is a DBMS which running at one site will be taken care by the database administrator of that single site. And there may be many number of sites in distributed database. Why? Because data is distributed over across various sites. So they assume that there are n number of sites. Data is distributed various n sites. Now that n number of database administrators also will be existing at n number of sites. Okay, now a distributed DBS database administrator is also there who coordinates with all these particular local database administrators, and then they will collectively take a decision what type of data should be stored at that site and what type of data will be stored at other site. So we have a local schema concept and we also have a global schema concept. So what is local schema is what type of data is stored locally and which is not relevant to this local site and which is relevant to global site. That type of data is stored at a global level. Okay, that's why. So whenever we are accessing a query or whenever we are going to executing a query, we require to consider local query execution and a global query execution. We'll discuss about all those things when we come for query execution and then how we are going to do all those things. Okay, so first aim of our distributed is transparent management and distributed and replicated data. So not only data is distributed, the data is also replicated at 2 or more sites. For example, I'll just go for a small example so that it will be very much easy for you all to understand why the replication of data is required. Okay, for example, if you consider our State Bank of Hyderabad, State Bank of India, in our OU branch, there is a State Bank of India branch. Now, assuming that this particular State Bank of India OU branch is going to do 100 transactions locally, for example, per a day. Okay, 100 transactions locally and 100 transactions which is not of the same location. So, what do you mean the same location is? For example, the transactions which are done locally, and that there are some transactions which are done with other particular. That is also called as non-home branch transactions. One is home branch transactions, one is non-home branch transactions. For example, there are 100 transactions done daily for a local transaction. That is nothing but a home branch. Means retrieving of money or depositing money, who is having account in that OU branch. Those are all called local transactions, which are also called as home branch transactions. I think everybody knows that. And then there are also 100 transactions per day which are executed or which are run, which those 100 transactions are not belonging to the local site. These are called as non-home branch transactions. For example, I want to transfer some amount to Bangalore branch HDFC, Bangalore HDFC Bank, okay, which is of Bangalore. Now, there is some more transaction which is depositing some amount from Mumbai to this particular OU branch, one of the account holder. Like that, there are some transactions which are related to non-home transactions or which are called as non-branch transactions. Okay, non-home branch transactions. So now, for example, out of these 100 non-home branch transactions, if the network is not available, for example, network is down because of some issues, okay, there is no internet service provider, there is no internet service at this moment. That's why those transactions will not be done. Whereas local transactions can be done without any delay. Why? Because the data is stored locally in the same site or same server. Okay, so that's why we can get the transactions executed which are belonging to the same branch. But whenever the transactions which includes non-home branch intervention, then automatically those transactions to be completed means they require network, they require internet service, they require the permission of other branch also. All these things are also required. For example, there was a check depositing in my home branch account or in my OE branch account. Assume that I had issued a check which was given by one of my friend who is residing at Mumbai. Okay, he has given me a check of 5 lakh rupees. I just want to deposit that particular 5 lakhs which has been given by my friend in Mumbai. The bank check also Mumbai and Bank of Maharashtra check. Assume that was given by one of my friends. So I am depositing it in on my account, in which is there at Hyderabad OU branch, State Bank of India. I have gone there and issued the check, and then I am waiting until my particular account get deposited that amount. So I have given the check and then I'm waiting for that. So okay, and then the people who is sitting in front of the system, they are going to say that so it may take some more time, sir. Why? When I ask why, they say that the network is down at that moment. So wait for 1 hour or 2 hours. Then otherwise take our number and then inquire after lunchtime, like that he'll say. Why? Because the network is down. Once the network is down, okay, they can't deposit that whatever the amount that was there given by the check of my friend to my account. They can't transfer it. Why? Because it requires intervention of other branch and other bank also and other site also. It is not of same Hyderabad check. If you want to get the check to be deposited of local branch, so that will take 1 day. But non-local branches and non-other branches, it may take 2 to 3 days. Why like that is, so they want to get the approvals of that concerned branch. And then why that approval is required? For example, that 5 lakhs of rupees in that account which was given by my friend, whether that much of minimum balance is there in that in his account or not, whether that 5 lakhs, more than that 5 lakhs is there, then only they can get that approval. Otherwise, they won't get that approval from that so and so branch. That's why. So we require to get all those things. To get all those approvals and to get all those communications, we require internet working also, and this particular thing is required minimally. That's why. So since whenever a non-home branch transactions are to be executed, so out of that 100 transactions, now we are coming to our topic. Why I am taking this example, I'll tell you now. Every day in a OU branch, a State Bank of India, there are 100 transactions which are executed as a home branch transactions. Now assume that another 100 transactions are also there. These 100 transactions are belonging to other branch, non-home branch. It may be any other state or any other particular district, or it may be any other state. That is different case. It may be overseas also. Okay, so all these things out of this 100 non-home branch transactions, assuming that every day, out of this 100 home branch transactions, assuming that Maharashtra branch, that means we are getting from Mumbai or Pune or somewhere, so that branch transactions are 25%. Means 25 transactions are exclusively from Mumbai of some other HDFC bank, assuming that. So now, or some other particular bank, whatever it may be. Now what we will do is now we are going to replicate the data in, that means these transactions are going to be executed here. Instead of that, we can also replicate the data. Means out of this non-home branch transactions, in which non-home branch transactions are executed, so there we are going to replicate the data. Means not only the data, already we discussed about that thing. That means distribution means not only executing not only the data is distributed, that logic, the function, or the whatever the particular thing, that execution also can be done at other sites. So now what we can do is, instead of getting the data from those sites, we can also send this execution to that site. Okay, so that's why data is replicated here and there. Once the data is there replicated here also in the local site, then automatically I can, without having any communication delay, without having any networking, without having any issue with the internet, we can execute it locally. When the data is replicated, means for example some Bangalore branch SBI data is also available in Hyderabad OE branch. then automatically instead of sending that, asking that approvals and getting the information from the Bangalore batch, we can directly get the data. Since it is replicated here also, assume that there is one more copy of Bangalore batch details here, then automatically we can get it locally and you can get the transactions very much fastly. So even though data is distributed at various sites, because of data replication, which is also called as replicated data, we can execute those type of transactions which related to the data which is replicated in this site, then automatically you can fetch it locally and then we can execute the that type of transactions very much fastly without having any delay of communication delay, or it may be execution delay, or it may be networking delay. All those delays can be reduced when the data is available locally. Okay, that's why there is some replication of data is also required to make execution faster. When those type of transactions which are frequently done, those type of frequently data can be replicated at 2 or more sites also. We'll see about that part thing also. Okay, so now we'll discuss one of the aims of distributed, that is called transparent management of distributed and replicated data. Okay, now transparency refers to separation of higher level semantics of system from lower level implementation details. So what do you mean by that is, so it is going to suppress, or it is not going to show all the details. It is going to show the data to your user, whoever asking the data, thereby not allowing the users to dig into the matters, that is dig into what the things are going on inside. So they don't want all those things. They want the data, whatever they have been asking, that's all. So okay, if they are asking some data, the data is provided by the DBMS. Okay, it is not going to show you, or it is not going to allow you to what actually where the data is stored, whether it is replicated or not, whether data is distributed at various sites, all those internal, that is called higher level semantics. That higher levels of semantics all are separated actually from lower level implementation details. So the implementation details are there at a lower level. They are also called as physical level. In the physical level, where the data is stored, and then how it is stored, in which type of databases it is stored, in how many number of tables it was stored, what are those particular key constraints that are implemented, all those implementation details are at low level or at physical level, and higher level is only the operations. So whatever the query has been posed by the user, that query will be sent across the higher level layers to lower level layers, and then the lower level at lower level the data is existing, that will be given by the higher layers, and higher level layers will get the data, and then that will show according to the requirement of the user, whatever that user is asking. So that is also, that means higher level details and the lower level details, there is a clear separation. Higher level details will be asked by the users, and that only we are going to take help of them, and then take the inner, we'll dig inside and we'll get the implementation criteria, and then we'll just get the data from the lower level, and that will be again sent to the higher layer, and that higher layer implementation, they are going to use whatever the structure of the data that has been asked by the user, and in that structure only we are going to present it to the user. Okay, are you following the things now? So that is called as a transparency. That means whatever that is required will be shown to you. How we are getting will not be shown to you. That is called as management of distributed transparency. Are you getting now? Transparency refers to the separation of higher level semantics of system from lower level implementation details. Okay, how we are going to implement, how the data is fetched, from where we are getting, all these details will not be shown to the users. The users will get whatever the data they are asking. That in what way? Okay, how they are asking, we are going to give. But what they are asking, we will give. From where we are getting, what we are doing internally, that will not be shown to the users. That will not be given. We can't show also. Why? Because a lot of things are there internally. Okay, that internal details cannot be shown. That is hidden from the external purpose or external usage. Okay, that is called as a, the transparency is maintained because of the separation between high level semantics and low level implementation details. That separation is supposed to be maintained by us. Okay, the next one is from data independence in centralized DBMS to fragmentation transparency in distributed DBMS. Okay, so how we are going to maintain this, how we are going to manage the independence in centralized DBMS. In centralized DBMS, okay, so we use the term called data independence. So what do you mean data independence is, even though there are some changes made at high level, that particular high level changes should not affect the low level physical level changes, physical level requirements of changes. And then if at all we change at physical level, that should not affect your logical level. So, this particular thing, physical layer, that is called levels of data abstraction in your DBMS, that which have been already come across by all of us. So, levels of abstraction means at the lower level, we have a physical level. And then next, in the middle level, we have a conceptual level. And the high level, we have views. There are different type of views, view 1, view 2, view 3. Okay, so even though you are having any changes in conceptual level, okay, we don't have any botheration to change it, or necessity to change, or requirements to change the physical level. Means data at the residing at the tables should not have any effect on, if at all you are changing at the conceptual level. So that is called physical data independence. And then, so we also have conceptual data independence. And then whenever they are going to change the conceptual level changes, that should not affect the physical layer. And then whenever you are changing at the physical level, the conceptual level should not have any change. That is possible only because of separation about between these two. That's why from data independence in centralized DBMS also we require to maintain in our distributed DBMS at local sites. And also we require to have another particular responsibility, that is nothing but fragmentation transparency in distributed. What do you mean by this? Fragmentation transparency means, okay, so there are different type of fragments. So what do you mean by these fragments means, the data, for example, you are assume that our State Bank of India has 4 branches. Assume that there are only 4. One is at Hyderabad. Okay, forget about various branches in Hyderabad. Just we are considering that Hyderabad's database is stored at only one Hyderabad's server. That is called as ABIT's main branch server. So every data is stored locally. That is whatever the data produced and consumed in Hyderabad Hyderabad area will be stored in Hyderabad server. Assuming that, don't assume that that is realistically done, but we are going to store all the data of Hyderabad's State Bank of India data in the centralized server which is located at Hyderabad's ABIT's branch. Just assume. And then there are 3 more branches. We are discussing that there are only 4 different type of branches available in State Bank of India. One is Hyderabad's, and another one is Mumbai, another one is Bangalore, and another one is Chennai. Assume now they are distributed. Now I want to get the data, or assume that I am a customer or whatever it may be. You have been asking now. So what is the thing now? For example, I want to get that information of all the customers whose balance is greater than 10,000. Can anybody tell you how to execute this query? I want to get all the names of the customers whose balance is greater than 10,000. Anyone please respond?
Select name, whatever the table name, where balance is greater than the amount. I mean, whatever the balance is.
Balance is greater than 10,000.
Yeah.
So, but the data is not stored at one single na. It is located at Hyderabad. It is some particular data is located at Chennai, some data is located at Bengaluru, and some located at Mumbai. Then how we are going to write this type of thing?
We can specify the location name in the condition.
Yeah, that's the thing. What do you mean by fragmentation is, there are totally 4 fragments. What fragments? The whole table is not residing, or it is not at one single site. Now there is one fragment in Hyderabad's database, okay, server, and one more fragment is there at Chennai server. One more fragment is there at this particular Bangalore server, and one more is there in Mumbai server. Means when you join all these collectively at 4 sites, then only we can give some query. Okay, for example, if the query has been modified like this now, How? Find the names of the customers whose balance is greater than 10,000 from Hyderabad site. Means we can just get that local operation. It can be done in Hyderabad site itself. No requirement of getting information from all other particular sites. Why? Because it is locally executed at Hyderabad server and we can get that particular. Okay, but whenever a query is asked globally, which requires information from various other sites, not only all the sites, which requires information from one more than one site, which is there not residing at locally. That includes a global query execution type of thing. Now, in that case, so all fragments are supposed to be searched. Then only we can give the information correctly. So that's why that is called as fragmentation. Now, what you mean fragmentation transparency is the user poses a query. Automatically, the query is to be executed and whatever the data that has been asked by the user should be provided for him without knowing him that the data is located at various other sites. It may take some more time, or it may take some because of network delay, it may be getting delayed, or because of some other reasons. No, we should not get all these things. If the query has been asked by the user, it is the duty of distributed DBMS to get that data from wherever the site, wherever it is located, and it should give to the concerned ask. That's all. So that's why fragmentation transparency says that whether whatever the data has been asked by the user should be given to him without showing the details of where the data is located at various sites or whether it is there at one single server. Okay, that is called as fragmentation transparency. Means the transparency says that is fragmentation transparency says that the query asked by user will be given to him, like whether the data is stored at local site. Okay, he should be unaware that the data is getting from various sites. That is, data is fragmented at various sites. No, it is not going to be shown to him. He will get a notion that, or he will be in a notion that the data is getting from a local server or local system, which is which is shown to him in front of that particular person who is sitting on the dumb terminal. So that is the thing. That's all. Likewise, data is getting from the same computer the person is sitting, whoever the particular person is sitting in the bank, that is getting from that local system. He should be aware that also. Not more than whether it is getting from Mumbai, whether it is getting from Bangalore or like that. That is called as fragmentation transparency. Now, what is the question here is who should provide transparency? Now, who is the person, or who is the background? Who is to be implementing all these transparencies? Okay, so what we require to do? What is one of the main aim of distributed DBMS is transparent management of distributed and replicated data. Now, he is not telling about replicated data here, but we'll just, when we go deeper and deeper, okay, how the queries are executed, then we'll get a replication of data also. Okay, so data is fragmented and also data is replicated also. We'll discuss about replication of data when the time comes in detail. Okay, so now this particular fragmentation transparency and also implementation transparency, all these transparencies are to be implemented by distributed DBMS. Okay, yeah, please, anyone? Any doubt here, please? Okay, I'm carrying on. Okay, so who should provide this transparency is only one, that is called dist. Now, distributed DBMS is not a person. Already we know that. That's a distributed DBMS is to be implemented by the database designer, like us, whoever. For example, if we take up a job of database designer, we require to design the database. We require to provide distributed DBMS services. Okay, so that all these transparencies should be taken care of. Okay, so that's about the one of the aims of distributed database DBMS is transparent management of distributed and replicated. The next aim is reliability through distributed transactions. Now the transactions are going to be executed, whether local transactions, whether it may be global transactions, whether it may be or distributed transactions, we don't know. Generally, it will be distributed only. Why? Because we are concerned about distributed DBMS. That's why the transactions compulsorily, when they are locally they will be executed without any doubt or without any network delay, without any global execution of the transactions. But the thing is, when a distributed transaction is there, means distributed transaction means a transaction which is executed not locally. Apart from local transaction means it requires data fetching from various other particular sites also. Then that is called as a distributed transaction. Now, the distribution transactions, whenever we have been taken care, the reliability is one of the most important. So already we came across your this particular thing. So reliability is one of the most important. Why? Because if it is not reliable, then automatically whom we can ask. So the data itself, whatever we are getting, if it is reliable, then only we can carry forward. Otherwise, what is the use of that? That's why reliability means what? Whenever a query has been posed, it should be answered or it should be given. So when a query has been asked, automatically the data should be given. Okay, it may be delayed for some particular seconds of time, or it may take in some 20 seconds or maybe 50 seconds. But what do you mean by that? Data reliability should be maintained. Okay, so reliability through distributed transactions also is one of the main aim of our distributed DBMS. So now, distributed DBMS can use replicated components to eliminate single point failure. Now he is now in deeper, or he is getting showing the importance of this replication of data. Now, one more example or one more usage of data replication also he is is going to point out. What do you mean by that is, if a single point of failure is there, if the data is stored at that site itself, okay, if that site was failed because of network failure or because of site failure or because of power problem there or any other particular problem, whatever the issue might be, if that site is failed, and it means if the site is not on, it is out of our network, then automatically all the transactions which require information retrieval from that site will be in dangling state. They have to wait until the site is up. Otherwise, we have to wait until the site is up. That is the trouble. Means if the if all the data is stored at that site only, if the site is failed, then automatically everything has to will go into a standstill. That's why one of the reason for replication of data, he is saying that replication of components. Okay, not only this particular storage, he is also replicating some processes. He is also replicating some other particular, for example, if we think of computer networks, which particular topology you feel is better? Can you tell me which topology is better in computer networks? Various topologies are existing to connect between two or more different systems in the computers which are there existing in the network. Which type of topology you feel is more better? Anyone please respond. Star topology. Any other than star? Maybe tree topology, maybe star topology, or it may be a ring topology, or it may be what we can say is a bus topology. Apart from all these things, there is one thing. Anyone?
Mesh.
Very good. That is called mesh topology. So what is the trouble here in the mesh topology is, can you tell me what is the trouble in the mesh topology? The advantage is very good, but what is the trouble in that mesh topology? Or what are the drawbacks of mesh topology?
It's expensive.
That's it. That is one of the most important thing. Okay, it is most expensive actually. It is very burdenous to a particular this network design. Why? Because for every point to point, for every particular system to all other systems existing in the system, there should be a separate connectivity. Okay, so even though there is a network failure from one side, the other side we can reach. So why? Because from assume that there are A, B, C, D, E different types. There are 5 different type of systems. To connect 5 systems, We require 5 into 4, that is 9 by 5 into 4 is 20 by 2. So we require to have different cables. How many cables now? A to B, A to C, A to D, A to E. And then from B also, B to already A to B is there. That's why there is no requirement of connectivity again from B to A. So B to C, B to D, B to E. From C, C to separate D, C to E, and then from E to separate. So totally 5 plus 4 plus 3 plus 2 plus 1. So this many number of particular cables we require separately from to have a mesh topology. So that means, so this many number, that means 5 plus 4 plus 3 plus 2 plus 1 is what? How many? 5 plus 4, 9, 9 plus 3, 12, plus 2, 14, plus 1 is 15. Okay, so 5 into 6, n into n plus 1 by 2, not n into n plus 1, n into n plus, that is 5 plus 5 into 5 plus 1, that is 6. 5 into 6, 30 by 2, 15 cables are required. Okay, so to connect between 5 systems, we require 15 cables. Okay, if they are far away, you can just imagine how much of cost we require. That's why that is the most costliest one, but it is most reliable one. Okay, it is the most reliable. So that's why they generally, in our real-time environment, we generally don't go for mesh topology. In our computer, this particular lab, which is there existing in our software lab too, also not belonging to our mesh topology. They also belong to what type of topology in our computer labs, in our CSC department? Can anybody identified already? No, it's not bus topology. It's simply called as star topology. Okay, why? Because there is a separate hub. There is one simple one device called as a router. From the router, we are going to connect all 20 or 30 systems which are there located in the one lab. From that router, we are going to connect to other particular this particular lab, and from there, so we have a lot of hubs here. All hubs are connected to the main particular server. So like that, we have a star topology. That is the most cheapest particular thing. So we use generally star, but there is a ring topology also. There is a particular mesh. There is a token bus or token ring. There is bus topology also there existing. So in a bus topology, there is a high-speed cable, single cable, which is punctured at every juncture, and that will be connected to a system. So in our thing, we don't have any puncturing of any particular cable is done. So that is done only in a this particular bus topology. Okay, so we'll come back to our reliability. Now, reliability through distributed transactions is one of the most, or one of the aim of our distributed DBMS. And how this is achieved is, one of the thing is he is interpreting that if you repeatedly use some components at various locations, so thereby means processors we can increase, or we can increase storage devices at various places, and we can replicate some of the places, we can replicate the data also. So in that case, so even though one site is failed, the data is replicated some other site, the same data of that site is replicated some other site, we can get the data from that site, and thereby we can complete. Once this site is on, we'll get the data that is up-to-date data from other sites where the data is replicated. From there, we are going to download to this particular site. That also there. That the reliability can be increased by one of the thing which is called a replication of data. Okay, so distributed DBMS can use replicated components to eliminate single point failure. Okay, the users can still access part of the distributed database with the proper care, even though some of the data is unreachable. So if that data is unreachable from that site, since already that site's data is replicated at some X other site, the data can be gathered, or that can be fetched from that X site and get the things done without stopping or without any delays. Okay, but once this site is up, okay, the data whatever that has been up to date in that X site, that should be again copied back to the original site. So that is also proper care. That is called as a proper care. What is that proper care? So if the data at that can failed site, fetch the data from that X site and get the things done, which is replicated or without any delays. Failed site. Okay, but so the data is not, two different databases available means automatically it is not consistent. The data should be consistent also. Means what? So whatever the data that has been updated in X site, whenever this our original site is failed, the data should be again taken back from the X site to the failed site back. From there onwards, so both have same data. Once the original site has been updated, the same updation should be done with the X site also. If that X site has been updated, the same updation should be what done in the original site also. That is called as a taking proper care. Okay, so now the third point is distributed transaction facilitate maintenance of consistent database state even when failures occurs. That's what I'm considering now. So, okay, if the data is both are replicated, very good. Replication is very good. Why? Because if one or the two sites have been failed in the network, the database transactions will not have any effect. They can go on getting the transactions done or executed without any trouble because of the failure. Why? Because they can be available at some other sites. Like ABC sites are replicated at XYZ. Whenever there is a problem with ABC respectively sites, then we can get the fetch the data from XYZ sites respectively and get the things done. But the thing is, the consistency should be also maintained. So proper care should be taken care, and then that compulsorily that when you maintain all these things, then only because of replication of data, we can have one advantage. And other particular thing, once other side, what we have to take care is we have to take consistency also into consideration. One site, if it is failed, so whatever the site, wherever that data is replicated, we can get the transactions executed from getting the data from that particular site. But whatever the updations that have been done in that site, in the absence of original site, that data, whatever that has been updated, should be again taken back to the original site once the site is up. Thereby consistency can be achieved. Okay, so even though failure occurs, data consistency should be maintained. Okay, so another aim of our distributed DBMS is improved performance. So we require to take care of this improved performance. That means we will get that is the result of our distributed database. The result of distributed database is performance should be improved. Otherwise, what is the use of that? Okay, since each site handles only a portion of database, the contention of CPU and IO resources is not that severe. So you should understand this thing carefully. So since the data only a portion, for example, there are 10 sites, the database is distributed. So each and every site has more or less 1/10 of database. Okay, all these 10 sites are distributed. It is not exactly 1/10. It may be some more or some less also. Okay, so it is not exactly distributed. Okay, the database size is not distributed. Okay, the distribution is possible only because of their local transaction. Okay, their geospatial things. It also use that. Okay, since each site handles only a portion of database, the contention, that means the usage of local CPU and local IO resources will not be that much severe. Contention of CPU and IO resources means usage or burden on the CPU and burden on the input output resources will not be that much severe. Okay, so means 1/10 of transactions will be done by or handled by that site only. Okay, so each and every site has the more or less 1/10 of frequency. The automatically that is not more burdened. Okay, so what is the thing? The data localization reduces communication overheads. For example, local transactions are done locally. Okay, without any intervention of computer networks, without any intervention of this internet connectivity, without intervention of any global transactions. Directly, local transactions can be done locally without any hurdles. So that's the thing. That means, so local, almost 50% of transactions will be local transactions. There we have another 50% of transactions executed, which are global transactions. Okay, but local transactions can be done or can be executed without any overheads, without having any communication overheads. Okay, so that's the thing. Next, inherent parallelism of distributed systems may be exploited for interquery and intraquery parallelism. So what do you mean by this thing is inherent parallelism of distributed. That means distributed systems are paving a path for us to execute some transactions locally and some transactions globally at the same time. Means parallelly some part of query is executed locally, some part of query is executed globally, thereby increasing the performance. Are you getting this now? So what is the thing is because of distributed systems, because of this particular thing, inherent parallelism is getting utilized. Means, no, we are not. What is our motto is to distribute the data wherever the data is locally available, and whenever the data is not available locally, which is there at some other site. So that site also we are going to connect to this site, and then we are making that total system as distributed DBMS. That is called distributed DBMS. Then what we are going to have is, thereby we are getting another advantage, that is called inherent parallelism is established, or inherent parallelism is achieved because of our distributed systems. Why? We can exploit this particular distributed environment. How we can exploit the distributed environment is, if a transaction is asked, assume that in the first particular case I have given a transaction called find all the names of the customers whose particular balance is more than 10,000. Okay, here I am not mentioning from one site. We should get all the information from all the sites. Now, this query can be transformed or translated in different way. How? So one query is asked, which is called as customer name should be what identified of those customers whose balance is more than 10,000. Okay. Now, the same one single query, that is called a global query, can be divided into four different queries, as we have four different sites. One is Mumbai, one is Hyderabad, one is Chennai, and one is Bangalore. Now, out of this particular thing, now one query is translated or modified into four subqueries. What are the four subqueries now here is? One is select name from customer where balance greater than 10,000 at Hyderabad site. Next, the same thing is done at Bangalore site. The same thing can be done at Mumbai site, and same thing can be done at Chennai site. Now, out of these four, all are independent. So one query is divided into four subqueries, and four subqueries can be run parallelly in each and every site. Thereby, parallelism is achieved now. Our intention is not to take help of or take usage of this particular, take advantage of parallelism, but automatically it is achieved. That is called inherent parallelism. Our intention is not to execute parallelly, but automatically we will go for parallelism. We will get that, we will achieve that as all are distributed and they all are independent. The same query can be executed at the same time at all the sites. That's why the interquery or intraquery. Interquery parallelism means what actually? If the query is executed locally, or if the query can be executed at various other sites. So for both the cases also can be done. In some interquery means what? For example, so we are going to get information from various other sites also. This is the example. And intra-query means what? In the same query, we are going to get, so means in the same particular site, I can also achieve parallelism. One is, for example, I'll tell you, like intra-query parallelism means only one site only we require to get that query executed. But how parallelism is achieved? I'll tell you. For example, I want to get a query executed for this particular query. What is that query? Find the names of customers at Hyderabad site only, okay, where whose particular balance is more than 10,000 and their age is more than 60 years. Means I want senior citizens whose balance is greater than 10,000. I want that. Now, what I can do is now I can achieve parallelism. I can take this query and divide into two queries. One is names of the customers whose age is more than 60, and in the second particular case, I will consider I will take the query or divide the subquery in other manner, like names of the customers, to find the names of the customers whose balance is greater than 10,000. This is separately executed. This is run parallelly. Why? Because both are different. One is performing on age and one is performing on this particular balance. So both can be combined, but you can use union operation on this particular answer A and answer B. Like if at all, if you use A and B, we'll get the A intersection B, not A and B. A intersection B means all the names of the customers whose balance is greater than 10,000 will be A, and what is B? All the names of the customers will be there here whose whose age is greater than 60. Age is at B and balance is at A. So all the names will be there here. Here also all the names will be there. A is names, B is also name. If I use intersection, common names will be identified. So that's also achieved parallelism also. That is called inherent parallelism. Our intention is not to do parallel, but we'll achieve parallelism because of this distributed environment. And the next one is performance models are not sufficiently developed. So now whatever the performance, whatever we are achieving cannot be calculated. Okay, even though intra-query parallelism is is there, or inter-query or intra-query parallelism is there, we can't achieve or we can't get that calculation of this up-to-date information of how much faster this query has been executed like this way and other way. So there is no perfect performance models till now which are supposed or which are till now developed, so that which can measure the their particular performance. Okay, so that's also not possible, but we are going to improve the performance. Another aim of distributed DBMS is easier system expansion. Means whatever the system is there, it should be expandable. Means, for example, there are 100 systems now. So tomorrow they can be expanded to 1,000 systems also. Okay, if there are 1,000 systems already existing now, and by adding some more sites, by adding some more particular, yeah, please. Yes, please. Anything you want to say, please? Okay, please mute, and then if at all you want to say something, you please unmute and please tell me. Otherwise, you please mute and then try to listen. Okay. What the thing is here? Easier system expansion. It should be expandable. So the thing is, even though there are 1,000 systems presently working without any trouble, your distributed DBMS, even though by adding another 1,000 systems, your distributed DBMS should not have any effect. Okay, so that is called simple expansion. Ability to add new sites, new data, and new users over time without major restructuring. So the major restructuring should not be done, but a minor restructuring can be done. Okay, huge centralized database system, that is like mainframes, are history almost. So, but I think every one of you know in the what is the Y2K problem actually arised earlier, and then what is the trouble with Y2K, and then in the before this year 2000 and 2005. Okay, all our Indians has been went to USA and then lot many other developed Western countries, and then have been worked in mainframes or mainframe systems by learning KICS and DB, CICS and DB2, and then this IBM mainframes. Okay, so IBM mainframes are nothing but mainframe systems which were installed by the all Western countries prior in 1960s itself, 1960s, 1970s itself. Why? Because their companies have been expanded globally earlierly in 1970s and 60s itself. Thereby, they have been using mainframes. Okay, so that I think everybody know about mainframe systems. Okay, but that is a history now. Nobody are using mainframe systems now. Everybody are using simpler systems with help of our distributed systems, distributed environment or computer networking. Okay, now PC, that is personal computer. Personal computer revolution, that is compact, buying digital 1998, like all those things, not only compact, lot many other things, IBM's also there now came into PCs. Okay, personal computer will make natural distributed processing environments. Now, whatever the PC revolution that has been appeared in 1998, like in the year 2000, it has made a natural distributed processing environments. Why? Because all the personal computers, thereby having an internet connectivity, so each and every particular system can also be useful, or it can be seen as a distributed processing environment. Each and every one has their own processing capacity, their own storage, their own processor, their own each and every particular systems. Every personal computer has all these things. Okay, so their local ability has been improved. That's why each and every personal computer, whatever individual system is there, that is also a perfect computing environment. It designs that. So if I join more or 10 to 20 systems, that the huge performance also will be seen. Okay, now what we can see is now because of this revolution, so our computing and processing environments has been increased. Their capacity has been enormously increased. Okay, new applications such as supply chain are naturally distributed centralized systems with just not will not just work. Okay, simply joining systems cannot work properly. Why? Because thereby adding more number of computer networks and by adding more number of cables, adding something cannot work. Why? Because not only distribution is it is not only sufficient. It is necessary, but it is not sufficient. What is sufficient is a system which build upon all these things, which is called as DDBMS, distributed DBMS. That system will make our systems perfectly distributed, and perfectly transactions should be executed without any trouble, without any hiccups, and then performance, thereby increasing the performance and maintaining the consistency. And then all asset properties also should be implemented. All these things is done with the help of your distributed DBMS. What he's saying is, combining all centralized systems and combining all these things will not work. Only it is not going to sufficient. Which is sufficient is a simple distributed DBMS. Okay, so that's about the thing. Now next one is complicating factors. There are some other factors which are more complicated to maintain all these things. One is data may be replicated in a distributed environment. So compulsorily data is replicated, thereby reducing regular usage of some sites. Okay, instead of regularly using that particular sites, we can repeat that particular, or we can replicate that particular data in the other site and make the things work very much faster. Okay, in a distributed environment, data replication is done. Therefore, distributed DBMS is responsible for one. First one is choosing one of the stored copies of requested data and making sure that the effect of an update is reflected on each and every copy of the data item. That is one of the things. Means, so where to replicate the data, what data is to be replicated, and select what type of data, whether from original site we have to get or from the replicated site. Which one is near to us, which one is going to make our things faster. That also should be decided. That has been chosen by our distributed DBMS. And also, second thing is, once there is an update done on a particular site, if that is replicated to our other sites, two or more other sites, the two or more other sites should also get this updated to be done. That also should be taken care by our distributed DBMS. That's most important. Next one is maintaining consistency of distributed and replicated data. So maintaining consistency of distributed and or replicated data. That also is one of the major important. Next one is, since each site cannot have instantaneous information on the actions currently carried out in the other sites, the synchronization of transactions at multiple sites is harder than centralized system. So whatever the update that has been taken care, or whatever, once that update has been taken place on some data item, the data item of local system can be updated very much faster. But if that is replicated to two or other sites, the two or other sites replication should be done after the completion of today's transactions. Means all the transactions, whatever that has been done today, but 4 o'clock, everybody can imagine, or you can just understand this thing. So this replication and synchronization is done at 4 o'clock. Once that, I am telling you, in a real-time environment, all the banks will stop working at 4 o'clock. They will just stop, for example, 4 or 4:30, whatever, that ending time. Still, the bank is closed for the customers. The customer transactions are not taken care. But the bank staff will still work after that time also. Another 1 hour, 1.5 hours, they are going to work. What is the purpose? All the transactions still now done on that day, end of the day at 4 o'clock or 4:30 at the end time. So all those things should be taken care. They should be synchronized. All those things should be updated. Wherever the replication of data is there, that will be replicated. All those things will be concluded at that 1 hour or 1.5 hours. That is the time taken by the management or the staff of the bank to make all those things intact. They will make that ready, and then they will just go back. That's the thing. So to make all these things, synchronization and other particular things, so the complexity is increased by the distributed DBMS, and also cost is also increased, and then distribution of the controls also to be taken care by the distributed DBMS, and security. One of the other major aspect is also security. So all these things becomes our units. For example, complexity. So what is the complexity behind our distributed environment? That is also our second unit. And the cost and other distribution of control, that is our second unit, third unit. And security. Okay, all the security aspects is our fourth unit, I think. So we just think about all those things. Okay, in the fifth unit, all advanced research topics. Okay, now what are the different problem areas we would have is distributed, where we require to improve our distributed DBMS things is, first one is distributed database design. While designing the database, so we require to think of distributed. That's why, so where to distribute, what data to be distributed, and how the data is to be designed. That is one of the problem area. The next one is distributed query processing. The query, how the query processing is done, And then the next one, distributed directory management. So where the directories are going to be stored and what are the different type of directories to be managed, how they are going to collectively manage, all these things will be taken care. Distributed concurrency control. Now concurrency control means what? Even though there is some interleaving, we will get the whole effect as one after the other. Okay, but the thing is the net particular effect should be same. Okay, how this is done in distributed environment, that is called distributed concurrency control. Next one is deadlock management, which is called distributed deadlock management. Next one is reliability of distributed databases. Now operating system support. So whatever the support should be taken care by the operating system, all these things. Next one is heterogeneous database. Homogeneous database means all the databases are similar, but heterogeneous database. For example, here we are using a query execution by using Oracle. There somewhere in some other particular site we are using SQL Server. Now SQL Server operations are different and Oracle's operations are different. So even though a query has been asked globally, every query should be get executed and we should get the output. So okay, if that is homogeneous database are there, it's okay. But whereas whenever there is heterogeneous database, how to taken care of all those things should be considered by distributed DBMS also. All these are called various problem areas that we are going to take care of in the next hour topics. Okay, relationship. There are a lot many relationships, but that relationships you can just identify. That's not a same thing. So transparency and architecture issues in DBMS. There are some architecture issues. So this is also one of the important aspect. So what are the various architectures? Okay. So for example, there is a top-down DBMS or distributed DBMS architecture, which is also called as classical. First one is global schema, fragmentation schema, allocation schema, and then local mapping schema. Local mapping schema is for every DBMS, there is a local database that is located in site 1 and in site 2, site 3, there are not many number of sites here. There is a local mapping schema will be there, and there is a local DBMS implementation, and there is local database storage. So in that site 1. So there is allocation schema. Whenever the allocation schema is there underlying of all these things, so it is going to allocate various sites to that particular query to be executed. Fragmentation schema. Now site independent schemas are there. So they can directly go to allocation schema. And so if there is site dependent, so automatically fragmentation schema we have to implement. Okay. Like the global schema is divided into fragmentation schema if it is fragmented at various sites. And then allocation schema, what type of allocations to be, if it is not, fragmentation is not done. So that is called one of the classical schema, that is called top down. So in that case, how the particular global relations will be there, and then how the fragments are there, how the physical images will be there, that we can just see. On the left hand side, we have a relation, only one relation. It is seen as one single table called relation, that is called global relation. And we have R1, R2, R3 dash dash, that is called fragments. That one relation, that is called one customer relation or one customer table, is divided into three particular things: R1, R2, R3. Why? Because one is at R1 is there at Bangalore site, R2 is there at Hyderabad site, R3 is there at Chennai site, and R4 is there at Mumbai site, for example. And in R1 also, now there are R-1 and R-2. Okay, R-1 and R-2 are nothing but one actually, which are there at same site 1, but they are different now actually. So R1 is now combination of that particular thing and this particular thing. And R2 is a combination of R-2 and R2-2. And then it may be a combination of R2 R3 dash also. So that's why we may have different type of schemas. That's why whatever that there, which are their physical images, that also there at a third level. Okay, now there are some rules for data fragmentation. One is completeness, one is reconstruction, and one is disjointness. This is most important. Completeness means what is, all the data of global relation must be mapped into fragments. Compulsorily, whatever the data is there, the total thing, all the data that of a global relation should be mapped into fragments, into different type of, it can be cut into various fragments. Reconstruction. Now, reconstruction is possible when you join all the fragments, you will get a table. It must be always be possible to reconstruct each global relation from all its fragments. Next, disjointness. There should be disjointness. If there are jointness, then there is no requirement of fragmentation. So disjointness, it is convenient if the fragments are disjoint, so that the replication of data can be controlled explicitly. Means now if a site 1 and a site 2 is there, now site 1's data is there stored at this one, and site 2's data is stored at site 2. There is a disjointness. They are all are belonging to this one site, right? The same data is residing at site 1. and all the data that are belonging to site 2 is residing at site 2. Like that we have. Just see this thing now. There are two types of fragmentation. One is vertical fragmentation and one is horizontal fragmentation. Horizontal fragmentation means what? The whole table is divided into row wise. Means all the data is divided into rows. Okay, they may be totally there are 100 rows. Can be divided into five different fragments. One is 20 rows, 20 rows, 20 rows, 20 rows, based on some criteria. And vertical fragmentation means the whole table is divided into 2 or 3 different tables. Means what actually? It is vertically divided. Means roll number and name. One roll number and class, roll number and percentage. Now three. So generally, for example, there is one table in which we have roll number, name of the student, his course, and then his subject marks of previous year, whatever. Like that we have, and percentage. Now in that case, I want to divide into roll number, name into separate fragment, vertical. And the next one is roll number and this percentage, and roll number and course. Okay, like that also we can divide vertically. So that also there. Okay, so we have fragmentation, different type of distribution transparency. One is fragmentation transparency, one is local transparency. Okay, location transparency means where it is located we should not aware. Fragmentation transparency means we should not aware. That is, we means here users. Users should not be aware of whether the data is fragmented or not. They should get the data. Then location transparency means the user should be unaware of from where the data is getting, from one location or from various other locations. That's called. Now local mapping transparency is there and no transparency is there. No transparency means everything can be hidden, not hidden. Okay, so about other things we'll discuss in the next class. Okay, we'll conclude today. Okay, so Suman, are you there, please?
Yes, sir.
Suman, are you? Yeah, please. Suman, please collect that whatever that whoever that was present, that whatever the attendance is there. You please take care of those particular things.
Yeah,
please.
Collected,
thank you.
Yeah.
Then it will be easy for me also. So that why? Because I'll just purely depend on you for this particular attendance. Please. Thank you all.
Okay, sir. Please share that
Thank you, sir.
present PPT also. He is not there. Huh? He has left.
Yeah, sir.
He has
left.
left.
Okay, bye. Thank you.
Bye bye.